welcome back to the series on scraping the Schaublin 70. Happy New Year. It's a New Year's Day here, bright, crisp day in Toronto. And if you've been imbibing the night before, this one might be a bit of a challenge. It's tedious work and a tedious topic, but absolutely central to the accuracy of a lathe. Getting that spindle that we've built correctly aligned to the bed and the tailstock. The considerable amount of work we've done so far on the headstock has really just focused on getting a spindle very accurately traveling or rotating within its bearing. Now what we have to do is take the bottom of the headstock and scrape it into perfect alignment with that axis of rotation, as well as get it into the correct height to the tailstock. The alignment tool, my version of a Kingway machine alignment tool, that I think has a few improvements, could be used for this work. However, given that the bed is a flat top and flat front, it's just as easy to set some parallels up on the surface plate. Actually quite a bit easier. Here's some video I did of the process. Hopefully this is understandable and makes it clear what I'm trying to do here. Okay, just finishing the initial phase of scraping the Schaublin 70 headstock into the horizontal plane of the bed. There's a second phase needed where we have to, there's a lip here that mates with the front of the bed. We have to scrape that, but I wanted to go over how we do this because there's a couple of key things here. The first is that you do not need a test bar that fits the lathe. Any bar will do. All that matters is that the bar is a consistent diameter and straight. So to understand what's going on here with this test bar and why it doesn't matter which way it's pointing, we've mounted a test bar in the collet, and you know there could be errors in the collet to the test bar. Is the bore of the collet eccentric to its outside diameter? Is the spindle bore itself or the spindle taper accurate? In this case, I know it's not. There's a small burr I have to grind out after I get all this done. But you see very expensive lathe test bars with tapers that get installed in the lathe at the manufacturers, and I've seen that being done to scrape in the headstock. That's really just a convenience. You don't need something that mounts to the spindle, and in fact doing so introduces a source of error. All you need is something round and straight. And whenever you're doing this work, you have to check you have to kind of prove out all the pieces that you're using. So I indicated across these granite parallels, and yes, they're flattened true to a tenth. I used an indicator mic to measure the diameter along here, and it's it's less than a tenth consistent diameter. It's a ground pin. But so anyways, the point is we have some confidence in this surface. We have some confidence that this is straight and true, indicated it in a small V block. So that's all we need. And what we're going to do is we are going to measure the spindle in two locations. Now I've already done the measurement here. The bar mounted in here could have error in it where it could be, if this is the headstock, the bar could be like this. So we will get a 180 degree version of it like so. The bar could be straight but eccentric, in which case we get a 180 degree version of it like so. Or the bar could have some wobble in it, in which case we'd get 180 degree reading, something like so. However, in every case here, if we bisect the angle, that gives us the true spindle position. So the trick is to take spindle readings here and here and here and here. Hopefully that can be seen in the video. We're going to look at what is the difference between this measurement and this measurement? If they're the same but opposite, we're good to go. If they're the same, or if they're zero, we're good to go. So that's fairly straightforward. The other thing that we know is if we, I'll just give you the measurements I just did. I have this as the dot up position, and I index off of one of the holes on this built into the pulley on this. I call that the dot up. Left and right are 0.6 of a thou and negative 0.1 of a thou. And then the dot down was 1.2 and 0.5. So in that case, this dimension here is equal to negative 0.7. We take that one minus that one. And here, 5 minus 1.2 is negative 0.7, which is interesting. If we sort of drew this out, we're starting at, say, 0.6, and we're going down to 0.1, so that we can see which way the slope is going here. And for the dot down, we started at 1.2, a little higher, and we went down to 0.5. Even though the difference of these two measurements is the same, we're still not aligned, because the true axis of the spindle is a line bisecting these two. So our headstock, this are parallel bars, our headstock axis is still sitting like that. So it's kind of sitting there like so. We want to bring this up. So we want to scrape off the back ever so slightly. When you're getting this close, it doesn't have to take much before you're like sawing the legs off of a table. All of a sudden you have no table legs left. You have to take very, very tiny steps and measure. You can see here's a sheet I've had on the go. I do little drawings like that so I don't get confused. And we whittle away at it until we reach one of these conditions where the line bisecting the sets of points or the angle is horizontal. Okay? And by horizontal we know it is either because call this the A, or the B minus A, if this is A and B, is either equal to 0 or it's equal to the opposite of D minus C. So I have a little bit more work to do. I have to bring that up 6/10. When I scrape this, by the way, if you can see there on that bottom surface, it's very, very easy. Because of this ledge, you can't twist it on the plate, so it would be fairly easily to end up with a sort of a convex surface there that would create a bit of rock. Even if that was very, very slight, you'd still get a pretty good print across it, because when you're printing it, you could be doing that ever so slightly. And we're talking tenths here, so it wouldn't be obvious when you're doing it. So how I scrape this to get this really nicely bearing all over without any rock is I put a little bit of relief in here. Then I had this area and this area in contact, would do the measurement and determine whether it had to come up or down and concentrate my scraping there. And I did it such that just very carefully with taking small amounts off, but as I brought right into the right height, I started to make contact here. So I feel we've got a surface there with it's scraped to quite a high level of bearing points, and there's no rock, and it seems to measure up really well. Okay, a few more rounds later, and here we are for another check. Dot up, I have got 3.2 to 3.2 to 2.8. So 3.2 to 2.8. Well, there's, yeah, 2 points between 2.7 and 2.8. Call it almost 2.8, which makes it 2.8 to 3.2 is just over 4 thou difference. 3.2 to 2.8. We'll index this 180 degrees, and we'll have a look here. Here we go from 3.1 to 3.6, which is plus 5. So I think that this is considered done. We've got 5 and a bit negative on the other side, sorry, 4 and a bit negative on the other side, and 5 on this side. If you split the difference between the two, we're less than half a tenth, which is I think so I think we're done. The other thing to just kind of have a look at is you get minimal movement here. I've got the bearing quite tight now. Take these annoying gloves off. If you press here, you see you get no movement at all on the indicator. So you know, I'm not deluding myself that the bearing's going to slop around in there. I do have some run out because there is a burr in that spindle bore taper that I have to address. The other thing to check is to put pressure on the headstock itself. And what I want to make sure is that the base is not like that, so that it would rock. I'm getting less than a tenth there. I don't know, there might be some grit or something, but you know, maybe a quarter of a tenth based on the indicator. So I think things are pretty solid, and I'm going to declare that done after way too much time. With the number of iterations I've done on this, but you can see all of these are, and I didn't write everyone down, but all of these are kind of my notes as I went along. It's just page after page after page after page after page. This is the same thing. More. These are notes on it. Probably close to it, but you know, it was a very long process, but I think we've got as close to perfection as I possibly can get. I think that's probably enough for a New Year's Day today. Plenty of more tedium to follow. Please stay tuned for the next video, and I do appreciate the likes and comments. Thanks very much.